If ingredient fears guide your food choices more than biology, this video might make you uncomfortable. Citric acid gets called black mold, and magnesium stearate gets called toxic. But when you actually look at the facts, both claims fall apart. Let me quickly give context to this conversation. I'm often challenged by other professionals about using supplements with patients and making recommendations with products that contain citric acid as well as products that contain magnesium stearate. The concern here is that products that include citric acid are ultimately derived from black mold, or that magnesium stearate is toxic to the cells. These statements are often emotionally driven. I can even hear it when I see the way that someone just asks the question or poses the question to me about this. And I notice that there's more of an emotional response here than there is the tendency to look at the full story, or certainly even to dive into the research. What I'd like to focus on with you today is, I know that these ingredients can sound problematic, but just something sounding a certain way doesn't translate into how it behaves in the human body. So instead of looking at opinions around citric acid and where it's sourced from, or looking at magnesium stearate as being toxic, why don't we actually take a look at the facts? Let's begin with citric acid. Citric acid, when used in supplements, is made from Aspergillus niger. That's an important organism to know about. And it's often stated as being black mold and therefore toxic. When many individuals hear this conversation, what they hear is that Aspergillus niger is black mold, and from that, citric acid is made. And so therefore, when you're using citric acid, I must be eating black mold. Here's the missing piece in that conversation though. Aspergillus niger is a production organism. It's not the final product. There's a difference between the fungus, the Aspergillus niger, that's being used to produce the end product, in this case citric acid, versus actually citric acid. Those two aren't the same thing. They're not one and the same. Aspergillus niger is used to create the citric acid through fermentation. And once that fermentation process is complete, once the citric acid is produced, Aspergillus niger, it's removed. When we talk about citric acid as a byproduct of this organism, it's literally the exact same citric acid that you're consuming when you eat, say, citrus fruit, an orange, a grapefruit, something of that nature. And regardless of the source, for it to be citric acid, it has to be defined by an exact chemical structure. So again, regardless of whether it's coming from the food source or it's a byproduct of fermentation, it's all the exact same structure. Here's where the terminology becomes a problem. This concept of black mold, understand that that is a non-scientific umbrella term. That's really all that is. And even if you dive down and you look in the world of toxicology or mycology, the sciences that specifically study these areas, when it's talking about black mold, it's not talking about Aspergillus niger most of the time. Mostly what they're looking at is an organism called Stachybotrys tritarum. And again, totally different than Aspergillus niger. When you start talking about these claims related to citric acid being linked to black mold, here's the reason that these claims fail. Calling citric acid black mold, it's all semantics. You're relying on association. There's no toxicological link between those things. And even when you go to Stachybotrys, right, the true black mold organism, even in that scenario, toxicity is going to be dependent on the dose, the exposure, the route of exposure, the person themselves, and it's not just the name of the organism alone. And all this nuance that I just laid out for you right there, all of that stuff disappears when you start reading about these things online or start watching content on this. Again, Aspergillus niger, it's just a production organism. It's not in the final product, and citric acid is citric acid. The second one we're going to talk about here is magnesium stearate. This is often stated as being toxic, and it's also suggested that it's going to be suppressive to the immune system. And this one seems to show up everywhere. This one comes in waves. I seem to get a lot of questions in waves around this one for some reason. Maybe something came out in a video and someone saw it, or someone read something somewhere, or a group read it. But here's the point. The claims around this are often stated as it coats the gut. As a byproduct of that, it's going to block nutrient absorption, and because it's affecting the gut, it's going to suppress immunity or have a direct toxic effect on the cells. But here's what actually happens. Magnesium stearate does not stay intact in the digestive tract. It dissociates, it separates. And when it does that, what do you end up with? Magnesium on one hand, which is an essential mineral, and on the other hand, you end up with stearic acid. Stearic acid is a saturated fatty acid that's found in a number of foods. Beef, cocoa, those are all examples of where you routinely find that in the diet. And we certainly don't label those as inherently toxic either. Anytime you use a mineral like magnesium, and I'll just stick with magnesium here, but this applies to other minerals, you have to bind that mineral to something when you're using it in a supplemental source. Otherwise, it's just inherently reactive. And so in this case, it's actually stabilized by the stearic acid, but again, it dissociates once it's assimilated or once it's digested in the stomach. Here's where this evidence gap between what's often stated and what the reality is here's where that gap lies. This immune suppression that we often hear about, these claims come largely from in vitro studies. In vitro is a cell culture study. It's not a human study. These findings haven't been demonstrated in humans at the levels that we're talking about right now. They haven't been demonstrated in humans, period, but definitely not at the levels that we're talking about. And when you look at why these claims fell, apart from just simply the fact that there is no actual research data, and even before I shot this video, I always go back and double check that, and I went through the literature again. I even did an assist with AI to have AI go back and see if I was missing something when I went through PubMed to try to validate what I'm telling you right now. And there's just no human evidence to show that magnesium stearate is a problem, and logically, when you think through it, there's nothing to suggest that it would be a problem. The manufacturing, it is used as an excipient, so it makes things flow better. But the dosing that we're talked about is microgram or milligram amounts at most. It's not these massive pharmacological dosages. In fact, if you ate a meal with a hamburger, you're probably getting more magnesium stearate. Let's assume you eat an overall healthy meal. You're probably eating more magnesium stearate or magnesium and stearic acid coming into the diet than you are in an entire bottle of a particular supplement. So it's not even comparable. And there really is no evidence about this coating of the gut, that it's meaningfully blocking absorption, or that in humans that we can show that it suppresses the immune function in any way. Everything that you read or hear about magnesium stearate, it's pure mechanistic speculation. There is no human data outcome on this. And because it has been used for so long across so many aspects of the nutritional industry, if there was a problem associated with it, after decades literally of use on this, you would see problems manifesting at this point. But none of that exists. This one's bunk. Here's 3 things that we can take away from this conversation. Production methods don't equal biological effect. Associations don't equal toxicity or contamination. And speculation doesn't equal human data outcome. Ingredient fear usually doesn't come from bad intentions. It comes from partial information, especially when that information is taken out of biological context. Citric acid, magnesium stearate, well, they follow that same pattern. And a claim may sound scientific, but it doesn't survive human evidence. And this exact pattern shows up again when you start looking at supplements to help with performance. If you've heard strong claims about creatine, what it does, what it damages, or who should avoid it, you'll want to watch this next video. Creatine misconceptions that just will not go away. This is going to give you separate mechanisms beyond the speculation from real-world physiology.